Hello, lovely 3H students. Today we are going to talk about how we can recognize and identify key transformations of functions by their equation. So a couple things that we want to go over. First, we have our quadratic function. The key that you're looking for here is that square term. So every quadratic is going to have a squared x somewhere along the way. So that's what we're looking for when we're looking at the equation. We're looking for that x squared component. Okay, so what is my value of a? A being, of course, that piece that's being multiplied or distributed to those x's. So in this case, 2. And what is that going to do to my function? It's going to stretch my function, right? Every output will double. It's going to stretch it out. H in this case is a positive 3 because the mother function, or the graphing form of the equation says minus h. So if you actually still see the subtraction sign, it's a positive h value. My k value is 5. Okay, so what is the vertex? The vertex is always h comma k, so the vertex here is going to be 3 comma 5. It is a vertex, not a locator point. So when we graph it, the vertex will be at 3, 5. Okay, absolute value. Key here is now we have just a plain old x by itself. Notice not squared, cubed, nothing like that. The key we're looking for here is these absolute value lines that indicate that we have an absolute value function. Okay, so over here we see this is going to be an absolute value function. The principles of a, h, and k are exactly the same as they were before. So a is going to be 1/2. It's going to compress my function. Every output will be half as large. My h value in this case is -1. Again, I don't see the subtraction anymore, so it must be a negative h value. And then my k value is 9. Again, this is a vertex, and it will be at -1, -9. So we will get something that looks like this with our vertex at -1, -9. All right, this is a square root function. Pretty straightforward, right? The key to a square root function is, of course, that square root. So that's what we're looking for to identify what this function is. So again, this is a square root function. The a value is -2. It's going to both flip and stretch my function. Flip and stretch. Every output will double, but we'll go the opposite direction. So we're going to go down, concave down for this guy. Oh, actually, no, this is different because this is not a parabola, it's a square root function. So it's actually going to end up being concave up because it would have been concave down before. So it flips and becomes the opposite. And I'll show you a rough sketch of that in just a second. H is going to be -5. And our k value is going to be -8. We call the end point of this, it's actually an end point for our square root function. We call it the locator point. So what we would normally have if we had a positive square root function would look something like that. So when we reflect it and it flips, it's going to now look something like that. So this would be the rough sketch of what that function would look like. Again, it's a square root function, so it's just, yeah, and reflected. Okay, what is my a? Well, first of all, this is a cubic function. So what are you looking for when you are looking at a cubic? That cubed. Now our x value is being cubed. So my a in this case is going to be -1/3. It's going to both flip and compress. Wow. Compress my function. My h value here is 0 because there is nothing being added or subtracted from that x. And my k value is 1. This is a cubic function, so we call it a locator point because it's that curvy thing, and the locator point is just in the middle where it curves. So what you're going to have is a negative. So normally a positive cubic function would look like this, right, with my locator point right in the center. A negative cubic function is going to be a reflection of that. So it's going to look something like this one here. So again, opposite direction. So what was increasing the entire domain is now going to be decreasing the entire domain. Okay, how about a cube root function? A cube root, well, again, now what we're looking for is that cube root, and a, h, and k will be similar, will be in the same location for all of these. So this is going to be 4, a negative 5h value, negative 7k value. This is, again, a locator point. This is another kind of curvy one, kind of like the cube function, only sideways. So it's going to look something like this with our locator point right there. Again, I would highly encourage you to play with these in Desmos to get a feel for what they look like, but that's just a rough idea. Okay, in this case, my a value is 3. It's what we actually multiplied that numerator by. So the a value in this rational function is going, and again, what would the key be here? The key for a rational function, we're looking for that fraction, the fact that we have a fraction, two functions being divided by one another. So this fraction line here is the key to identifying a rational function. A value is 3, again, what the numerator got multiplied by. H is going to be a positive 9 because I can see the subtraction sign. Whoa, diggity. And K is going to be 2. I didn't even put what these vertices were. Let's go back and do that. Okay, so this is going to be a locator point. Again, it's going to be the intersection of the two asymptotes, the intersection point of those two asymptotes. So this one would be 9, 2. Let's go back and do our vertexes here. This is going to be negative 5, negative 7. Again, it's always HK is that locator or vertex point. This one would be 0, 1. This one is going to be negative 5, negative 8. And I did it on the first one. Okay. All right. So now how can we graph these? Well, again, always create an XY chart when you need to graph something, but let's just kind of get a feel for what all of these mother functions look like. Okay, so remember, we can always create an XY chart, and again, you want to get really comfortable with the most basic version of all of these functions. So spend a little time with this. Again, play with the transformations in Desmos, see what's happening here. Okay, so I always like to pick a couple values to the left of my locator point, a couple values to the right of my locator point, so I can get a feel for the whole function. Now notice on all of these mothers, these are all mother functions, and because they're all mother functions, the locator point is always at 0, 0. So the vertex or the locator point of every single one of these is going to be 0, 0. So I'm always going to pick like negative 2, negative 1, positive 1, positive 2. Okay, so negative 1, negative 2, 0 is going to give me 0 every time, and then positive 1 and positive 2. Okay, when I take negative 1 and I cube it, I get negative 1. Negative times a negative is a positive, times a negative again, spits out a negative. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. Positive 1 cubed is positive 1, and positive 2 cubed is positive 8. All right, so now we just have to graph that. Negative 1, negative 1, negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, positive, and 1, 2, 3, 4, 5. All right, again, a cubic function is that tall, skinny, stretched out. Again, remember, if you were to square it, you'd end up with the other side of like a parabola because we cannot get a negative out of a square. But because we're cubing, we can get that negative side. So we're going down and we're getting taller or we're stretching out faster because that cubed value. All right, a rational function. So now we're going to do the same exact thing for my rational function. So negative 2, negative 2, negative 1, 0, 1, and 2. 0 is actually not going to spit out a 0. In this case, it's going to give me undefined. So I know that's where my asymptote is. In fact, I'm just going to drop in my asymptotes here real quick. My vertical asymptote would be at x equals 0. The equation of that asymptote is x equals 0. And then my horizontal asymptote is going to be at y equals 0, y equals 0. Again, because this is the parent function. Okay, so negative 2 is going to give me 1 over negative 2. This is negative 1, positive 1, positive 1/2. So negative 2 down 1/2, boop. Negative 1 down negative 1. Again, we know these rational functions curve and approach the asymptotes. Again, cannot touch the asymptotes, but they're going to infinitely approach them. And then this curve is going to look like this. All right, so the most basic version of a rational function. Okay, x squared. This is our parabola. Hopefully this is kind of ingrained in your brain at this point. 0, 0, 1's going to give me 1, negative 1 is also going to give me 1, 2 is going to give me 4. Oops, that's a 3. 1, 2, 3. No, that's 4. Here we go. Okay. And there is the graph of your mother parabola. Again, get super, super comfy with that one. Okay, x, y. Now we're going to do the cube root of these. With that in mind, I might pick slightly different values so I can actually get whole numbers out. Something to consider. So instead of -2, I'm actually going to go all the way to -8. The cube root of -8 is -2. Okay. -1 is going to give me -1. 0, 0, 1, 1, +8, +2. Again, I just picked actual values that have a cube root just so I could get whole numbers. You could have picked any value and gotten a decimal, give you the same idea. Okay, so 0, 0, again, my locator point in this case. When I go -8, 1, 2, 3, 4, 5, 6, 7, 8, down 2, boop. Okay, and then -1, -1, and then +1, +1, and then 1, 2, 3, 4, 5, 6, 7, 8, up 2. And again, this gives us a kind of sideways curvy bit, kind of the, well, if you think about a cubic function is like the vertical version of this, and then the cube root function is kind of the horizontal version of this curvy business we got going on here. All right. A square root function is going to give us just 1/2. We're going to get a bunch of undefined business here because we cannot take the square root of a negative. So if we were keeping with our -2, this would be undefined. Can't take the square root of a negative number. -1 would also be undefined. 0 is going to give me 0, 1, 1. Again, I might jump to a perfect square like 4. 4 would give me 2. Okay, so again, these have endpoints because of that undefined stuff. We cannot plug in negatives into our square root equation because we're going to get imaginary numbers, and you don't know how to graph those yet. So for now, until you get into lots of fancy math, we are going to not graph imaginary numbers. So 0, 0 is the lowest point on my function. That's my minimum. It's an end point here. And then we are going to go up from there. 1, 1, and then over 4, up 2. All right, and that is what the mother function of a square root function looks like. All right, now we have an absolute value function. Again, we're going to do our x, y. Remember that this is just x by itself, so it's basically linear. The key here, though, is we cannot get negatives out of this. We can't have any negative outputs because absolute value is a measure of distance, and distance cannot be negative. All right, so when I do -2, it spits out a +2. -1 spits out +1, 0, 0, 1, 1, 2, 2. So it's kind of like a parabola, but we're not squaring, so we're going to get straight lines instead of curvy lines. So 0, 0 is my vertex again, 1, 1, -1, 1, 2, 2. So we have a linear, but only positive, which is what gives us that vertex there. So it hits that minimum value, and then it's only going to go up in both directions. Okay, so first we're going to look at the equation. We're going to identify what the mother function would be. We're going to write the equation of that mother function, and then we're going to describe how it is transformed. Okay, so what am I looking for? Again, that key feature here is this square root. So this is a square root function. Okay, the mother function equation would be f of x equals the square root of x, okay, the most basic version of the function. So f of x equals the square root of x is going to be our mother function there. And then let's identify a, h, and k. So a in this case is 2. It's going to stretch my function. Every output will double. H is going to be a +3, so we're going to go right 3 units, right 3 units. And k in this case is 0, so no shift up or down. Okay, we didn't go up or down at all. All right, next, now we have a cubic function. So this, oops, let's try that again. This is a cubic function. The most basic version of that would be f of x equals x cubed. Let's identify a, h, and k. A is 1/4. This is a compressed compression, every output is 1/4 of the original. H in this case is +1, so this is a shift right 1. K is going to be -5, so we're going to go down 5. All right, this is an absolute value function. Again, key defining features are those absolute value lines right there. So this is an absolute value. A is -4, so this has 2 transformations on this function. We are both going to flip and stretch. Every output will be 4 times as large and going in the opposite direction. H is going to be -7, opposite of what it looks like in that equation there. So this will shift left 7. K is going to be a +9. So this is up, shifting up 9 units. So we're going to go up 9 units. All right. Now we have a rational function. I know I have a rational function because I see that fraction there. Okay. If I were to pull that 1/3 out, I could have 1/3 times 1/x, and that would be the same. So the A value here is actually 1/3. So that's going to compress this function. That's a compression. H is 0. There's nothing being added to that X value there. So that's an H value of 0, so no shift. And then K is going to be 12, so we're going to shift up 12 units. All right, last but not least, this is a cube root function. Again, looking for that key feature there. So this is a cube root. The mother I don't think I did the mother. Oh, yeah, okay. The mother function of this would be 1/x, right? And this is a rational function. So I didn't actually write that down, but rational and the most basic version is just 1/x. Okay, so this is a cube root function, and the mother would be the cube root of x. Okay, my A value here is 1/2. That's going to compress my function. My H value here is -6. So we're going to shift left 6 units. K is 0. There's nothing being added over here, so that's like +0. So no shift up or down. All right, last but not least, we have our quadratic function. We have that square term there, so this is my quadratic. The most basic version would just be x squared is the mother function of the quadratic. A in this case is 0.01. That's a really big compression, right? 1/100th. This is 1/100. So that's a significantly compressed. This is going to be a very, very squatty parabola. Graph it in Desmos, see what you think. Very, very squatty parabola. My H value is going to be -5, so that's going to shift left 5 units. And my K value is going to be -6, so we're going to shift down 6 units. And that is how you identify the mother function from the equation and what A, H, and K will do to the function. Hope that makes sense. Have a wonderful rest of your day.